All right, let's get into it. Making Electronics, second edition, Charles Platt. Where did this book come from? It was recommended by a couple of you folks, and I thought, well, we probably should go over it and see what it's like. Now, from the looks of it, you can already tell kind of by the cover, it's a more practical edition of electronics. It says hands-on primer for the new electronics enthusiast, okay, which will be very beneficial. I'm already going to, go out on a limb and say that it's probably very beneficial, especially for those who have been chiming in and saying like I don't really understand electronics, or I didn't do good in math and physics and so on and so forth. I've always wanted to learn. The books that we've reviewed so far, the practical electronics for inventors and art of electronics, both of those are better suited for people that have some kind of theoretical background. Both of those books are very steeped in basically electrical theory. They're not necessarily, they are in a sense practical application, but practical application for the person who has some background in theory. Now, this would be, as far as it looks, and I think it'll come to pass, and this will maintain and hold true, that this book is really for someone who doesn't have a lot of theory background, doesn't necessarily even want any theory background just yet, maybe really basic understanding just to get some projects done, but they're really wanting to get projects done and build some things, and then that will advance their theoretical knowledge, and they'll get deeper into it from there. Burn things out, mess things up. That's how you learn, okay? See, that's the kind of ethos of this book, right? So it's like you're not going to get it right the first time, you mess things up, and then you learn that way. So it's more learning through application here. So let's dive right into this. Let's see if we can get a little background here. There's some acknowledgments, some dedications. Who Christopher Platt or Charles Platt is, I'm not sure. Oh, maybe there might be some author's notes or background. No, maybe not. How to have fun with this book. Everyone uses electronic devices, but most of us don't really know what goes on inside of them. Learning about electronics can be fun so long as you approach the process in the right way. It is also very affordable. Knowledge of electronics can enhance your value as an employee, or perhaps even as a new career, a whole new career. Learning by discovery. Most introductory guides begin by using definitions and theory to explain some fundamental concepts. Circuits are included to demonstrate what you have been told. Science education in schools often follows a similar plan. I think this is as learning by explanation. This book works the other way around. I want you to dive right in and start putting components together without necessarily knowing what to expect. As you see what happens, you will figure out what's going on. This is learning by discovery, which I believe is more fun, more interesting, and more memorable. Working on an exploratory basis, you run the risk of making mistakes. But I don't see this as a bad thing, because mistakes are a valuable way to learn. I want you to burn things out, mess things up, to see for yourself the behavior and limitations of the parts that you are dealing with. The very low voltages used throughout this book may damage sensitive components, but will not damage you. The key requirement of learning by discovery is that it has to be hands-on. You can derive some value from this book merely by reading it, but you will enjoy a much more valuable experience if you perform the experiments yourself. Fortunately, the tools and components you need are inexpensive. Hobby electronics should not cost significantly more than a recreation such as needlepoint, and you don't even need a workshop. Everything can be done on a tabletop. Will it be difficult? I assume that you're beginning with no prior knowledge. Consequently, the first few experiments will be extremely simple, and you won't even use prototyping boards or soldering irons. I don't believe that the concepts will be hard to understand. Of course, if you want to study electronics more formally and do your own circuit design, that can be challenging. But in this book, I have kept theory at a minimum, and the only math you'll need will be addition, subtraction, multiplication, and division. You may also find this helpful, but not absolutely necessary if you can move decimal points from one position to another. All right, so that gives you a good basis. Like I said in the beginning, this is more about application, not much about theory, and he's already given you kind of a preface of why he wrote the book and what he wants your approach to be like. So he goes how this book is organized, so it has experiments, what you will need, cautions, fundamentals, theories, background. If something doesn't work, usually there is only one way to build a circuit that works, while there are hundreds of ways to make mistakes that will prevent it from working. Therefore, the odds are against you unless you proceed in a really careful and methodical manner. I know how frustrating it is when components just sit there and doing nothing, but if you build a circuit that doesn't work, please begin by following the fault tracing procedure that I have recommended. See fundamentals, fault tracing. So that's good. He's got looks like some literature or a chapter on how to troubleshoot. I will do my best to answer emails and from readers who run into problems, but it's only fair for you to try to solve the problems first. All right, so that gives us a pretty good background on this. So let's start going into the basics. Let's see if I can get a, oh, maybe there's not a table of contents here. Chapter 1, Experiment 1. Experiment 1, I want you to get a taste of electricity, literally. You'll experience electric current and discover the nature of electrical resistance, not just in wires and components, but in the world around you. Experiment 2, I will show you how to measure and understand pressure and flow in electricity, and finally how to generate electricity from everyday items on a tabletop. Okay, so that's what the first two experiments consist of. It'll show you the supplies. So he's showing you an analog meter. So just a multimeter here. Here's another one. That one's sold at Harbor Freight typically. You can find that. This is like a fluke style meter here. Some more advanced meters. It's going into some symbology. So that's the ohm symbol. That's usually the continuity symbol on your meter. Safety glasses, battery connections. So a 9-volt battery connection. There's your AA battery connection. Jumpers, potentiometers. Oh, my mouse clicks fast sometimes, so excuse that. That's a fuse, usually for automotive fuse there. This is just a regular fuse here. Cartridge fuse. Light emitting diode, the LED. People are pretty familiar with that these days. Resistors. Now I believe we're getting into this. So he really wants you to taste the battery. Okay, so bro, no more than 9 volts. This experiment should only be used with 9 volts. So he actually wants you to taste it better. Now, this is something I didn't advise. So when I was a physics teacher, we had a electronics and aviation club for after school, and my students definitely wanted to lick the batteries, and I warned against it. But he's encouraging it here. Very interesting. So here are your leads for your multimeter. Here's how to set it up. The common is ground, which is black, and then your red goes on the volts. If you need to measure anything like current, you have to use these two tabs. And remember that you have to put when you measure voltage in parallel, and when you measure current, you measure that in series. Now, here's a chart of a scale of ohms and degrees of ohms, okay? Here's how you'd set it up on a multimeter. Here he's displaying, looks like battery flow. Here I guess he wants you to vary the distance between the probes. He's getting you to measure the, I guess, the resistance of your skin. There looks like some history there. Some word on lithium batteries. More on batteries and flow. There's a chart on voltage. What a millivolt looks like. So that's what we call a millivolt. This is how you're going to see it on like a voltmeter. Okay. If you had 10 millivolts, that's what you'd see on a voltmeter, like that. How to blow a fuse. So he puts a AA battery into a fuse. Does the same with the cartridge fuse. And I suppose this is a good way to learn, to see what happens, right? Because that'll show you that electronics does rely on physical connections, right? So if the physical connection burns out, then the circuit doesn't work. There's some background on the battery and some inventors. Some word about resistor colors. LED, how to use a resistor to hook up an LED. I like this depiction here because you see that he's got the short leg and the long leg, so the long leg is going to be positive, so that's something to take note of. Measuring your resistance. I want you to open up a potentiometer to see what's inside of it. That's kind of cool. You can see the wiper. Oh, now he wants you to hook up a potentiometer to the LED. Measure the volts and the milliamps. Now we're getting into putting resistors in series, resistors in parallel. So using lemons to light up an LED. Interesting stuff. Tools, how to cut wires. Here's going to be your breadboard here. Jumpers. switches, relays. Oh, relays right there. Schematic of a relay. That's like a trimmer pot, trimmer potentiometer. Some transistors, capacitors, speaker. Okay, now we're hooking up switches to your LED. Continuity. Here's some ground symbology, some battery symbology, and some voltage connection symbology here. It's your resistor symbology, your potentiometer symbology, some more switch symbology. That's what you would see on a schematic. These are symbols that you'd see on a schematic for an LED. Now he's showing you symbols for connections. So the old style, which is very much still something that I use, so this is showing that the wires are crossing, but they're not connected because it jumps over that. The newer style, they just have a discontinuous line that goes through. Conventional, it just went through like that, and they just leave the dot out. So if there was a dot there, that means it's connected. If there's just crossing, then it's not connected. Now he's showing you how to operate a relay. Break open the relay. He wants you to open up a relay to see what's inside. So you're going to see the coil and the magnetic switch. This is some pretty cool stuff. I don't really recommend, breaking all your parts open, but that's a good way to find out. I think what that does is it really brings everything down into reality, let's say, because sometimes we see all these gadgets or all these components and all these things, and we just think they're esoteric, like they're from another world, or there's something that's built in some kind of lab or manufacturing facility, and they're like, we have a way of talking about electronics as if they're discovered but not created. But in fact, they're created, and they're just created by the principles that we know by our best science, and we compile those principles into some kind of process to make a component that exudes some kind of function. Okay, it's not necessarily that we've just discovered this thing and it's just this object that works in a miraculous way. No, it was designed and engineered that way by principles. And you can see that very much when you open this and you say, oh, that's just a coil. That's a magnet in a coil. Or, oh, that fuse is just basically a thin wire and it can only hold so much energy before the wire burns up. And it's like, okay, yeah, that's kind of like basic physics. You see that kind of stuff all the time. Getting into capacitors, so that's going to show you your picofarads, nanofarads, microfarads. Microfarads is going to be what we use most often. Some capacitor symbols. That's a non-polar cap. This is a polarized capacitor here. That's what happens when you burn up a breadboard. I've never had something like that. Never seen anything like that, but hopefully you haven't either. It's going through breadboard connections. This is something I think is very important. You should pay attention to. So this is like the bus. So the outer two are the bus. Typically, you can use a breadboard basically however you want, but it's made to be used in this way. So what happens is that you'd have these rows and then you have these columns, and you'll have a bus on one side and the other. You can choose which one's going to be positive or negative, and you can jump wherever you want power to be. Okay. Here's another breadboard schematic. I was never really into breadboards. I did most of my stuff on, soldering through-hole parts. Now he's going into some theory about capacitance. And I think his theoretical explanations are pretty, I think are pretty in-depth. They're not as light as I think that he made it out to be. Now we're looking at some transistor symbols, NPN, PNP. Adding a potentiometer. I don't know exactly what he's trying to do with this. Maybe to show that there needs to be a certain amount of current that needs to go through the transistor to make the, okay, so this pot is going to bias the base, and that's going to allow electricity to flow into the diode here. The light emitting diode, that is. Oh, and we're getting into like a flip-flop circuit here, or LED flasher. Looks like we're getting into an amplifier. Now we're getting some soldering tips and what tools you need to solder, diodes, wire connections. This is still very early on in the book, it seems, so I can't find my page readout, but okay, it's 300. We're on page 300 out of 848. What he's showing you here looks like okay, just some conversion for measurements. A magnetic switch. The alarm circuit. Very typical kind of things that you'd see from beginning electronics. Okay, now this is how to read part numbers for an IC, or seems particularly for like a CMOS or a logic gate. It gets into like a digital CMOS chip and display. 555 timer, again another very common component that we're going to talk about in the beginning of electronics. Showing you some timing. This is like a timetable depending on the value of resistor or capacitor that you have in the circuit. Then some background on the inventor. The siren circuit, it's basically an oscillator. Here's how to solder, how not to solder. Looks like we're putting the alarm into a package. Oh, here he's showing you how to actually, you could use that alarm device. So when it's engaged and those magnetic switches go off, then that would turn the circuit on. So a practical use for something that you built, which is pretty cool. Now we're getting into some kind of display. Voltage regulator. Logic gate diagram. Looks like more logic gate examples here. Some binary. Which, I mean, see, some of this is kind of, I would consider this kind of advanced. I mean, it's on the basic level of advanced, but it's kind of more advanced in a sense if you're getting into all the logic gates. And those are, I mean, those are definitely things that, oh, look, he has our books. He has our books here. He's got examples of books. The Encyclopedia for Electronic Components, Practical Electronics for Inventors. This is a massive, comprehensive book, well worth the $40 price. Despite in its title, you won't need to invent anything to find it useful. It's a primary reference source covering a wide range of concepts, from basic properties of resistors and capacitors all the way up to some fairly high-end math. So see, he's got art electronics, and he has the art of electronics, and he has practical electronics for inventors, both on his list here for reference books. See, so we're not alone here in our assertion of the value of those materials. And the electronics, the Encyclopedia of Electronic Components, that's not one that we've reviewed, but maybe we need to. We're on page 600 here. Looks like we're nearing the end, getting close to it. Now we're talking about inductance here. Speakers. Audio amplifier. Oh, looks like the radio is making an antenna. That's, I think, a very useful experiment. A lot of physics in there. Oh, it even has some more Arduino going on in here. I wonder what he's going to get to building it. Looks like some coding stuff. Maybe just basic thermistor. Also, basically how to use the Arduino to turn on an LED, probably, looks like. Or how to make it flash. You can do all kinds of things with that. Page 800 here. This looks like just reference material, yeah, and we're getting into like an index here. Okay, so that really, I think that brings us to an end here. Okay, so about the author. So, became interested in computers when he acquired an Ohio Scientific C4P in 1979. After writing and selling software by mail order. He taught classes in basic programming. He wrote 5 computer books during the 1980s. He writes science fiction novels. Okay, so he seems mostly self-taught for the most part. So this is Charles Platt, and that was Making Electronics. So what do I think of the book? I think it's pretty good. I think you just have to keep in mind, though, that you don't have to do everything in the book. I would say the most valuable stuff was probably there in the beginning with the LEDs, some of the relay stuff, the flip-flop circuit we see here, the radio at the end, some microcontroller stuff if you want to get into that. That's pretty popular today. A lot of uses for that. Maybe some of the amplifier and speaker stuff. As far as really learning some of the more theoretical stuff, but at a basic level, I feel like some of the logic circuits were like this stuff where you got a logic chip and 2 5-5 timers. It looks like an amplifier there too. It's pretty complicated, so a lot of things could go wrong with that, and I don't think it's going to necessarily enhance that much of an understanding if it gets too complicated. So I would spend more time on the simple circuits, the real simple stuff here. I think that would definitely give you a good basis for electronics. Now you can do some of the more basic logic circuits. But again, I'm not to discourage anyone from going all in. I'm just saying, as part of his motif and as part of your approach to wanting to learn, you keep it simple. And he does get a little bit even more complex than I thought he would, especially again with some of these logic circuits, because again, kind of like he stated, he does want you to struggle with it, but you want to manage your level of difficulty so you're not discouraged and you're not spending a lot of time fussing with something that you don't understand yet. So the difference being, logic circuits and stuff don't necessarily operate on the same level of physics as a lot of these other things do. So some of the other circuits, there's a lot more scientific background that you'll learn from doing them. Now, one thing I would recommend in this case, especially with these logic gates, is that maybe he would reference the data sheets and maybe encourage you to look at the data sheets. Now, if you were to take that route, I would be much more comfortable in using some of these devices, because then you get to really see what the manufacturers had in mind and how to use it and operate it. So that would give you a little bit more of a background of it. So in either case, I think it's a pretty good book. I think definitely a good intro to electronics for someone who's just brand new to it and wants to learn something and build a couple circuits, and then maybe you can even riff off on your own. That's one thing I'd like to see maybe more on this book is like a creative element to it, meaning give somebody 10 components and say, hey, what can you make with this? Draw a schematic out of some kind of idea that you have that you can make with these parts. I think that would be a little bit more beneficial than going way complex with some of these things. I think just having a blank slate where you can create some circuits yourself and learn from that, I think would be beneficial as well. But that's Making Electronics 2nd edition with Charles Platt. I hope you guys enjoyed the video. If you didn't see my post earlier, we're now up to 3,000 subscribers, so we're making a lot of headway. I again appreciate you guys for watching the content and supporting the electronics community and science education. There's a lot more to come. Just stick with me. I'll see you soon.